Hello friends, welcome in HK Tutorials. Today we will discuss about basic heat transfer, how heat transfer take place from one end of a rod to the other end, supported by the calculations. So let's take an example that this is our basic heat flow equation. Okay, that Q by A is equal to minus K dt by dz. This here Q indicates the heat, amount of heat, and A is the area, K is the thermal gradient, and del T dt by dz is the change in temperature, a small change in temperature on at a small distance. Okay, and generally for a given material, the thermal gradient is constant. Or for this calculation, we are integrating this equation. Thermal gradient should be constant. So B after integrating, equation become like this. Okay, where Q is the heat, del Z is the change in the distance, A is the area, and K is thermal gradient. Okay? T2 is the final temperature, T and T1 is the initial temperature. We can say at the end we are calculating. T1 is the initial temperature and T2 is the final temperature. Okay. Now in our example, we are taking a rod. I will make the rod. Yeah, whose dimension is means. Let us Now let us start the analysis. Uh, 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 okay, so just drag and drop this steady state thermal into the this area, and it will take some time. Here, this is our analysis window. Now here the engineering data, we see the right sign. It means that it is the data means the material of our geometry is already inserted, and this material is structural steel. This is by default material. So we will do analysis on this only, and now we will make the geometry for our analysis. So right click on this, and after right clicking you have to or click on new geometry, or you double click on the geometry, then it will direct us to the design modular where we will make our geometry. Okay, this is the design modular interface. Now we will make geometry. So take xy plane, sketching, and rectangle. Normal to this is our rectangle. We will give dimension to it at our calculation according to our calculations. So dimensions and general. Okay, here I put the this vertical dimension as 1 meter, and this dimension is 10 meter. Okay. Oh no, this dimension is 0.5 meter. Okay. Now zoom in, and I will go to modeling tab and then extrude here. And if I select the geometry, this geometry, and then I apply this, and operation should be add material, and the depth I'm taking here 10, because in calculation we will do calculations on 10 meter. Okay. Now click on generate. So our geometry is generated. Look at this is our geometry. Okay, now we will close this design modeler, and this data will be saved to our geometry in the workbench. Okay, now this tick is right, means our geometry is successfully imported. Now double click on the model tab in order to do analysis, or in order to perform simulation. This is our geometry which is imported here. Mass is not updated or not generated. First we will discuss about mass. As my other video tutorial series in which I discuss about massing. So for massing, this is a simple geometry. We can prefer any mass, but for the detail of mass, you can watch that videos. Okay? And this relevance and sizing I am doing here medium. Okay. Now I will right click on this and generate mass. Okay, this is the mass. In the steady state thermal means input variables we are applying from here. We apply from here, and in this right click inside. First we will apply this temperature. At one end we will apply. First we will perform the calculation. Then only okay. At one end we will apply this temperature as 100 degrees Celsius. Okay, and at other end we will apply a heat flow in our heat flux. The heat flux at this end will be like 100 Weber. Now we can update our solution or we can solve this. It will take some time. Our solution is completed. We can shift this to little downward, and now we want to see the results. So here right click on the solution, insert and thermal, in which we have to see this temperature on, and we also want the reaction. So because for the calculation reaction is needed, or we can calculate the reaction also. So just drag this temperature and drop on the solution, so it will add a reaction probe. Okay, now we will right click on this solution and evaluate all results. Okay, now our result is evaluated. This is our resultant graph. Okay, at this end we apply our flux, means heat flux at we apply heat flux at this end. Okay, and temperature, where is the temperature? At this end, 100 degrees Celsius temperature. Now we will change this in a smooth contours instead of lines. So this is our end. Minimum temperature is 100 as we applied, and this is the maximum temperature 116.53. Here now we perform calculation on the reaction probe. We see here the report is the reaction. So the reaction here is 50. So now let's go for our calculations. This is the temperature. Here, after this equation, we have to just simply put the values. So here our Q is 50, means Q, what is the Q? That flux multiplied by area. So in the flux, had put our flux as 100, and our area of cross section was 1 meter vertical and 0.5 meter horizontal. This area will be 0.5 meter square. So if we put here zero point 0.5 into heat flux, then we will get Q as 50. Okay, 50, and then our difference in both the end is 10 meter, as the length of our bar is 10 meter, and this is A means area, which we already calculated, that is 0.5 meter square in SI unit, and thermal conductivity constant is 60.5 for that material. Hmm. Plus T1 is 100, as we already applied at the end, and we will call the T2 as 116.53. This is our calculation, and also here we get maximum this as 116.53, means our calculations exactly match with this solution. Now we can this here in this details we can find that in the results minimum is 100 degrees Celsius and maximum is 116.53 degrees Celsius. Okay guys, thank you for watching this video.